Okay, now we are looking at another example still relating to the graphical method. So this time we want to solve real simultaneous equation using the graphical method. Now we are given two equations. So this is the first one. We are given 2x minus y equal to 1 and x minus 2y equal to 4. Okay, so as usual we are going to make here the x part, here the y part, here the x part, here the y part of it. Now now you notice that the question didn't give us any range of numbers to use. So to solve with this, you can just use small range like 1 2 3. It's okay, as in I mean making your x 0 1 2, so you can even make it 3 4 5. That is if you have time. So but I think 3 points are still okay to give you the exact line you need and to meet up with the points. So we want to do only for 0.012 of x, so we're going to put 0 1 2. So the same thing here, just 0 1 2 0 1 2. Okay, so now we need to find this our y. So for this table, this is the equation we're going to use. So let's make y the subject of the formula for this part, so we can easily get our y. So we're given, so to make y subject of the formula, we're going to move this to x, this plus 2x to this other place, so change to minus y equal to 1 minus 2x. Okay, now we need to remove the negative. We multiply both sides by minus 1. Imagine multiplying both sides by minus 1. Going to give us y equal to minus 1 plus 2x. Remember, minus times minus is plus. Okay, which you can also rearrange. You can just rearrange it as y equal to 2x minus 1. You are still saying the same thing. Okay, now let's find our y when x is 0. So when x is 0, our y would be 2 times 0 is 0 minus 1 minus 1. So this one we have minus 1 here. Now when our x is 1 minus 1, we're going to have 2 minus 1, which will give us 1. So this place is 1. Now lastly, when our x is 2, it's going to give us 4 minus 1, which is 3. Okay, so this is 3. So we're going to repeat the same process for this other equation here. So let's make the y subject of the formula here. We are given x minus 2y equal to 4. So to get y, we're going to move this x to this other side. It's going to be minus 2y equal to 4 minus x. Okay, so let's remove this negative sign by multiplying both sides by minus 1. Multiply both sides by minus 1, you can remove that sign away and to still give you the same value, as in that's still saying the same thing if you do this process. So that is minus times minus here now is plus, so we have just 2y. Y here will be minus 4 plus, remember negative times negative is positive, 1x x. So finally our y would be, this will go down, that is minus 4 plus x over 2. Okay, or we can just rearrange this upside as x minus 4 divided by 2 is still the same thing. So let's find the y region now. Now when x is 0, y would be what? X is 0 here, so 0 minus 4 over 2. This will give us minus 4 over 2, that is minus 2. Okay, so again, when x is 1, that is 1 minus 4 divided by 2. This will give us minus 3 divided by 2. So minus 3 divided by 2 is minus 1.5 in decimal. Okay, so let's write minus 1.5. Lastly, we have 2 here, so y equal to 2 minus 4 divided by 2, which will give us minus 2 divided by 2, which will give us final answer as minus 1. So this part is minus 1. So let's put it in a graph. We're going to put the graph of this and the graph of this together. So wherever they meet, that's where we're going to locate our answer for this simultaneous equation. Now this is the graph, okay, and these are the values we got. This one is for the first one, that is 2. The first one, that is 2x minus y equal to 1. While this one is for the second equation that says that x minus 2y equal to 4. Okay, so this is our graph. Let's assume this is a graph sheet. Now if you notice, the scale of this one is 1 centimeter to 1 unit, both for the x and the y axis. The scale for this graph, the scale of the x axis is 1 centimeter to 1 unit, and the same thing for the y axis. I personally made it 1 centimeter, 1 centimeter to 1 unit. Okay, because 1 1 1 1, and we assume from here to here is 1 centimeter, and we are counting it in ones, that is 1 2 3 4. The same thing here, 1 2 3 4. So let's start inputting their points. For this first one, we have when x is 0, y is 1. So x is 0, this is 0 here, inside the middle is 0. Y is 1, this is our y 1. So we have gotten our first point here. So these are our first points. Next one, when x is 1, y is 3. X is 1 here, y will be 3. So let's trace it. This is 3 for y, and this is x. So let's say they meet around this region. Okay, and now when x is 2, y is 5. X is 2, y is 5. That is, go up around this region. Okay, if it's a big graph, you will see the lines. So I might not be really accurate in the way I'm measuring it like this with my hand. So we have another from this next equation. We have when x is 0, y is minus 2. So x is 0, y is minus 2. This is minus 2. So this is where the point is, inside there. We have another when y is 1, when x is 1, sorry, y is minus 1.5. This is 1 minus 1.5 means within this range. 1.5, it's around this time, so we're going to trace it like this. So it touches 1 and 1.5. So that's it there. Again, we have when x is 2, y is minus 1. So x is 2, y is minus 1. This is minus 1, and this is 2. Okay, so the points touch this area. So what I'm going to do now, we're going to connect those points. So for this first equation, this is the point we got. So let's rule this point first. Okay, so we've ruled the line for the first equation here. So this is the first equation here. This is the line for the first equation for the 2x minus y equal to 1. So we have to rule this next line for the second equation. So we've ruled the line for the second equation, for this second equation, that is x minus 2y equal to 4. So this is the line for it. Now you can see where the line cross each other. That's where we're going to get our answer from. Okay, so the line touched this region here. So if we link it, this is minus 3, and if we link it up, this is minus 2. So where the point touch, just trace it up and down in your graph sheet. Okay, so make sure it is perfect, the ruling is perfect So you look at the lines well. So it touches minus 2 and raise it to here, it touches minus 3. So that means our final answer here is that x is equal to minus 2. This is on the x-axis, y is on the y-axis, and our y equal to minus 3. Okay, so this is the answer to the simultaneous equation that we just solved here.